Hi students, now we are going to solve problem number 11 in current electricity based on this circuit diagram. In the figure below, the ammeter reads 0. This is the ammeter which reads 0 current. The value of R is, the value of the resistor R we have to find out. So one of these 4 options. So first of all, in this circuit there is no current flow in this branch B, C, D, F. Okay, so in this branch there is no current flow. So I am going to consider the loop AB. Okay, AB, E, F, A. In this first loop, there is a cell of EMF E1 is equal to 12 volt, and the current sent by this battery is I ampere. This I ampere current is flowing through the resistance 5000 ohm between A and B, and the same current I ampere is going to flow through this unknown resistance R, because no current is going to flow along this path BC, and then it will reach the negative of the cell. So I will write the I into R product. So this is IR product is I into 5000 plus I into R. This is equal to the algebraic sum of the EMFs in this smaller loop. So in this small loop there is one and only cell of EMF E1 is equal to 12 volt. Now the current is leaving the positive terminal of the cell. Therefore this must be equal to plus 12. Okay, so this must be equal to what? Plus 12 volt. Okay, so now common factor is what? I into 5000 plus R is equal to 12. This implies I is equal to 12 divided by 5000 plus R. So this is equation 1. This is equation 1. Next, you look at this branch B, C, D, E. In this branch B, C, D, E, since there is no current flow in this loop, there is a battery. There is a battery or cell of EMF E2 is there. So the IR product, the potential drop across this resistor is parallel to this cell E2. Therefore, this IR product must be equal to what? This EMF of the cell 2 volt. So I into R is also equal to 2 volt. Okay, so I into R, this is equal to 2 volt, and this is equation 2. Look at the two equations we have got. The first equation is I equal to 12 divided by 5000 plus R. I am going to substitute the first equation in the second equation. IR is equal to 2. So in place of I, what shall I substitute now? 12. So this is 12 into R. Okay, 12 into R divided by 5000 plus R. 5000 plus R. So this is equal to 2. Okay, so this implies 12R is equal to 2 into 5000 plus R. So this is 12R. Okay, 12R is equal to 2 into 5000 is 10,000 plus 2R plus 2R. This implies 12R minus 2R is equal to, so 12R minus 2R is equal to 10,000. So 10R is equal to 10,000. This implies R is equal to 1000 ohm. R is equal to 1000 ohm. So we have got the unknown resistance value R is equal to 1000 ohm. So which option is correct is D. Option D is the correct answer. Okay, therefore option D is the correct answer. Have you understood? Okay, now one more small problem based on a closed circuit. You can see the question number 12, the current in the circuit below. So here there are two cells of EMF 7 volt and 3 volt. They are connected back to back. So they are connected back to back. So now you can see that the positive of the cell is sending a current of I ampere. Let us imagine that the current is flowing in the clockwise direction like this. I have assumed that the current is flowing in the clockwise direction. Okay. Now the battery of EMF 7 volt is sending the current, and now you can see that this battery, now it is a 3 volt, the negative terminal, the current leaves the negative terminal. So though there are two cells, of EMFs 7 volt and 3 volt, the net EMF is plus 7 minus 3. Understand? 7 minus 3, because 7 volt is positive because the current leaves the positive terminal of the cell, and 3 volt is negative because the current leaves the negative terminal of the cell. And in this closed loop there are only two resistors, namely 7 ohm and 10 ohm. So applying Kirchhoff's second rule or voltage rule. So I am going to apply 7I plus 3I. Okay. So this is 7I plus 3I is equal to this 7 minus 3, that is equal to 4. So 10I is equal to 4. So I is equal to 4 by 10 is equal to 0.4. Okay, it is 0.4. Okay, I have assumed that the current is flowing which direction? Clockwise direction. Now there are two options, 0.4 ampere in the direction A to B, B to C, like that. A to B, there is no flow actually. Is it not? The current starts from the battery. Therefore, the answer is what? B, C, D, A. B to C, C to D, D to A, and then only lastly it is completing the path. Understand? So the answer must be what? 0.4 ampere in the direction B, B to C, C to D, D to A. So the option is B. Okay. So option B is the answer. Okay. Now we will see the remaining problems.